Dr. S.P. Patil. In this video, we discuss about the Bainbridge mass spectrograph. So initially, I will draw a diagram. This is beam of positive ion. These are the slits S1 and S2. Now this is the velocity selector. This is velocity selector. Magnetic field is there. Okay. These are the electromagnets. Or we can say that plates A and B. Slit S3. This is photographic plate. Okay. And this is uniform magnetic field is there. Okay. Now, Bainbridge mass spectrograph, it is a device or instrument used. First use of this spectrograph is to detect presence of isotope. Also, it is used to determine the mass number of isotope. Second use, for determining the mass number of isotope. So we should know what is meant by isotope. So isotopes are elements having same atomic number but different atomic weights, and that is nothing but the isotope. Okay, so this mass spectrograph is a device or instrument used to detect the presence of isotope, and also it is used to determine mass number of isotope. Okay. Now Bainbridge use a power electromagnets, okay, and velocity selector in his mass spectrograph. During the year 1933, during this year, Bainbridge designed a a mass spectrograph which is shown in this figure. Okay. Now after that we discuss principle of the Bainbridge mass spectrograph. Very simple principle is there. Listen carefully. So whatever be the velocity of the positive ion in the process of their generation, it is made perfectly homogeneous in the velocity by the use of this velocity selector. After that, they are subjected or placed in a uniform transverse extensive magnetic field and brought to focus on a photographic plate. So this is the simple principle of the Bainbridge mass spectrograph. Understood? One more time I will explain principle of the Bainbridge mass spectrograph. Very simple principle. Listen, whatever be the velocity of the positive ion in their process of the generation, okay, it is made perfectly homogeneous in the velocity by the use of this velocity selector. Then they are subjected into the extensive transverse magnetic field and brought to focus on a photographic plate. So this is the principle of the Bainbridge mass spectrograph. Understood? Now we will discuss or explain briefly. For this, consider a beam of positive ion collimated or passed through the slits S1 and S2. Okay. After that, the beam of that positive ions enters into the velocity selector, which consists of electric field produced by providing the, understood? Here inside this velocity selector, the electric field is there, and that electric field produced by providing a suitable potential difference between the two plates. Okay. Now simultaneously magnetic field is applied which is perpendicular to this electric field and the motion of the ion. Listen carefully. This velocity selector pass only those ions having same velocity, and other ions are deflected from their original path and finally removed from the electronic beam. So we can write inside the selector. So here we can write inside the selector electric force becomes equal to magnetic force. Now electric force, we know that capital E into Q, or we can write E, small e, and magnetic force we can write B, Q, V. Okay, now here Q will get cancelled. Remaining equation we can write V is equal to E by V. Give equation number 1. Understood? Inside this chamber or cylinder, what happens? Electric force must be equal to the magnetic force. And electric force, we know that F is equal to E into small q, or E into, we can write small e. Small e or small q indicates the charge of the ion. Okay. Now here magnetic force B, Q, V. Now Q, Q will get cancelled. Remaining equation we can write V is equal to E by V. Okay. Now after that, the ions again passed through the slit S3 and enters into the uniform magnetic field. Okay. So under the influence of this magnetic field, again we can write under influence of the magnetic field, we can write magnetic force equal to centripetal force. So magnetic force BQV, centripetal force we can write mv square divided by r. Now this m indicates mass of the ions moving with the velocity v with the radius r. Okay. Now here also Vv will get cancelled. Remaining equation we can write Bq is equal to m v divided by r. Now again here we can write q by m is equal to v divided by br. Okay. Now here in this equation we put the value of v, that is E by v. So this equation becomes q by m is equal to E divided by b square into r we can write. Okay. Now from this equation we can write r is equal to, what we get? R is equal to E divided by m into E divided by b square or q into b square. So from this equation we can write r is proportional to m. Okay. Now after that these ions fall to focus or fall directly on the photographic fluid at different points depending upon the values of the mass. Okay. If the particle is lighter, then we get small semicircle, and if the particle is heavier, then we get larger semicircle. Understood? So finally on this photographic plate the traces are obtained. That is, and by using this we can detect or determine the presence of isotopes. So this is about the Bainbridge mass spectrograph. One more time I will explain principle and derivation. Okay. Very simple principle is there. Listen. Whatever be the velocity of the ions in the process of their generation, it is made perfectly homogeneous in velocities by using the velocity selector. Then they are subjected into the extensive transverse magnetic field and brought to focus on photographic plate. This is the principle of the Bainbridge mass spectrograph. Okay. Now after that, consider a beam of positive ions collimated, or we can say that passed through the two slits S1 and S2. After that, the beam enters into the velocity selector in which electric field is there, and that can be produced by providing a suitable potential difference between these two plates. Velocity selector pass only those ions having same velocity, and other ions are deflected from their original path and finally removed from the electronic beam. Now here B is there, that is magnetic field is applied and which is perpendicular to the electric field and the motion of the ion. Okay. So inside this selector we can write electric force is equal to magnetic force. We know that electric force E into Q is there. Magnetic force we know that BQV. So here QQ will get cancelled. Remaining equation we can write V is equal to E by V. Okay. Now after that ions or these ions again pass through the slit S3 and enters into the uniform magnetic field. So under the influence of this magnetic field, we can write magnetic force is equal to centripetal force. So again we know that magnetic force is BQV and centripetal force is mv square upon r. So this m indicates the mass of the ion moving with velocity v and with the radius r. Okay, so equation, we just arrange the equation of R, which is equal to m into E divided by Q into V square. Here only we put the value of V, that is E by B. So we get this equation. So from this equation we can write general equation, that is R is proportional to M. Okay. Now after that what happened? So again finally that ions fall to focus on this photographic plate, and they are focused or incident at different points, and which is depending upon the values of the mass. If the particle is lighter, then we get small semicircle, and if the particle is heavier, then we get larger semicircle. Understood? So like this, on this photographic plate the spots are obtained, and by using this plate we can detect the presence of the isotopes. So this is about the Bainbridge mass spectrograph. One more thing, this Bainbridge mass spectrograph used to detect the presence of isotope, as well as it is used to determine the mass number of isotopes.